Hello, this is Mr. Huber. This is going to be an answer key for the timed quiz regarding reference angles, reference triangles. And what we're going to see here is going through the problems. They might not be in the same order you saw them. Keep that in mind. But these will be the same problems that were on your quiz. They're just different orders for different students. So we'll just get going and work through these. So the first question here is, given that theta equals 245 degrees, we want to know alpha, the reference angle. So remember, the reference angle is always going to be drawn back to the x-axis. So 245 will be somewhere out here, but we're looking for this angle in here for alpha. Okay, not this one, not to the y-axis. Okay, so we're going to do 245 minus 180 because that would be our angle here. We've got 180 degrees around to there. So the angle we're looking for right in here, okay, would be 245 minus the 180. That will give us that little yellow part that's left over there. So that's going to be 65 degrees. Right? And given a reference angle of 27 degrees in quadrant 2. Okay, so a quick sketch here. So quadrant 2, reference angle 27 degrees. That's right there is 27 degrees. We want to find theta. So theta is going to be this angle going around to here. That's what we're trying to find. Okay, so in quadrant 2, the value of theta there with the reference angle of 27, we're going to do 180 minus 27, and that will tell us how much we have for theta, which is 153 degrees. Now, given an angle of negative 300, okay, negative 300, so that means when we start on the positive x-axis, we're going to work our way clockwise. Negative 300 will be something out here, right? That'd be theta is negative 300. We want the reference angle, so again, we're looking for this reference angle in here to the x-axis, reference angle to the x-axis, not back to the y-axis. That's going to be 60 degrees. It'd be 360 to get all the way around, back one full circle, revolution around the coordinate plane. So in this case, 60 degrees would be our reference angle. All right, moving up here a little bit, so we can see a reference triangle will always, this was the correct answer choice, be drawn perpendicular to the x-axis. Some of what I was just doing here kind of reference that. So, right, a reference triangle, doesn't matter what quadrant we're in. For in this quadrant out here, the reference triangle perpendicular to the x-axis. If I drew an angle that went around like this, right, my reference triangle still goes perpendicular to the x-axis. Okay, so reference triangle will always be perpendicular to the x-axis no matter what quadrant you're in or what axis you might be closer to. In a 30, 60, 90 special right triangle, so we're going to draw a 30, 60, 90 triangle here. Let's say this is 30 degrees here, okay, and we've got our right angle. The shorter leg is 1/2. That's across from the 30 degrees. It asks for the length of the longer leg. So we'll call that an x there, let's say. So the longer leg is the shorter leg times the square root of 3. Or in this case, square root of 3 over 2. That would be our answer, square root of 3 over 2. All right. Next says for ratios of trig functions in the coordinate plane, y is r always a positive value. Okay, the radius of a circle at the center at the origin. Okay, that's the answer choice. It was the correct one, right? The r is a radius. We want to keep that in mind. Where you're going to use x, y, and r values now. So if I have some angle, okay, drawn out to here, then if I draw a circle around there, that value r is the radius of that circle with its center at the origin. All right. And then we'll go to some other problems. So number 7 here, y is cosine negative in the third quadrant. Okay, the key things I was looking for with a problem like this is that cosine is equal to x over r. Somehow you write that out, x divided by r, x over r. Okay, so cosine is x over r, and in quadrant 3, x is always negative. R is always positive because it's a radius. Okay, kind of like what we talked about in the last problem. It's the radius of a circle, which is always positive. So cosine will be a negative over a positive. Negative x over a positive r will always come out to negative. So the things I was looking for there was to say that cosine was the ratio of x to r, x over r, and that x is always positive, r is always, or excuse me, x is always negative, r is always positive. So depending on how you might have had that worded, but those were the key things I was looking for your answer for that. Some people maybe talked about x being negative, never said anything about r, or maybe said x was negative, r was positive, but didn't say that cosine was the ratio of those two things. So making sure it's clear that you understood that part of it. Okay, there's a grading on that. That was when I graded manually. So that should help explain what I was looking for in that problem. And number 8 here, we have tangent is greater than 0. In what quadrants does the angle theta in standard position terminate? Okay, so if we remember from all students take calculus, okay, tangent's positive because tangent is y over x. So it's positive when we have a positive over a positive or a negative over a negative. Okay, so tangent's positive, greater than 0. And we have both positive. That happens in quadrant 1, where they're all positive. And it also happens in quadrant 3. Tangent's positive here because we have a negative x and a negative y. Okay, so your answer to this would be quadrant 1 and quadrant 3. Now we have given an angle theta in standard position that terminates through the point 8, negative 6. Okay, so I'll give myself a little room here to be able to draw a diagram. So 8, negative 6, that's going to be in the 4th quadrant. We have a positive x and a negative y, so we're going to have something like this. So here's the point 8, negative 6. 8 and 6, when we're looking at our triangle here to find our r, you can do 6 squared plus 8 squared equals r squared. 6 squared plus 8 squared equals r squared. Okay, r is going to come out to 10. You solve that. Okay, so now we've got an x, a y, and an r. Okay, sine is y over r. So sine is going to be negative 6 over 10, which is negative 3/5. Okay, tangent, all right, is y over x. So my y value is negative 6, my x value is 8. That's negative 3 over 4. Okay, sine is negative, tangent is negative. You want to make sure you have the negatives on both those. Cosine would be the one that's positive in quadrant 4. All right, so now we're going to look at 2 last problems here. All right, so we have tangent is negative 12 over 5 in quadrant 2. So we're dealing with something in quadrant 2. Okay, tangent, that's y over x. So negative 12 for the y. Excuse me, negative 12/5 is the fraction, right? So in quadrant 2, we're going to have the negative as the 5 and in the Schoology quiz, the fraction here was written as negative 12 over 5. When I converted it to this, it puts the negative and the fraction looks a little different. So when you have a negative fraction for tangent, all right, in quadrant 2, you're going to have a negative x comma positive y, right? So this point right here is going to be negative 5 comma 12. All right, that's the point negative 5 comma 12. The x would be the negative, the 12 would be the positive, or because it's the y value in quadrant 2. So cosine, all right, cosine's x over r. Well, I've got my x, that's negative 5. I need my r, okay? So I need to know that r value there. So I can do 5 squared plus 12 squared equals r squared. R comes out to 13 if you solve that. So my answer for cosine then is going to be 5 over 13, and it's a negative. Cosine's negative in quadrant 2 because I have a negative x value, the negative 5, so negative 5 over 13. All right, and one last one here. It says theta terminates in quadrant 4. So just idea, quadrant 4. All right, so we're going to have some angle like this. 7 over 25, so that's x over r. 7 over 25. All right, so in this case, I can do 25 squared equals 7 squared plus y squared. All right, so keep that in mind. Your r value there is your hypotenuse of this, and then you can subtract the 7 squared on both sides, and you get 576 equals y squared. And then when you square root that, you should get 24. So y equals 24. Okay, we need that because sine is y over r. So sine y 24 over r 25. And if you leave that as your answer, you're going to have a mistake there because, again, when we work with the triangle, this is why it's important to think of in terms of x, y, and r values in terms of coordinates. That's going to be 7 comma negative 24. Negative 24 for y. Also, remember, all students take calculus. You might go, oh, in quadrant 4, sign should be negative. And then you can go back, check that. Make sure on all answers, there should be no reason to get a sign wrong on an answer, whether it's positive or negative. Know which trig functions are positive and which ones are negative in the different quadrants. So you can avoid making a mistake because of a negative sign you either need or didn't have when you should have on an answer. Okay, so that runs through the problems there. Hopefully that would help. You can go back and review any of those as well that you might want to see again in understanding what the correct answers were for the quiz that we just had recently on this material.